We'll move ahead with a very important topic, which is on 3D printing. And we have our experts here. So we have Mr. Nitin Chaudhary. He is the partner in SRT System on behalf of 3D System USA. As I just mentioned initially, that 3D System USA is our knowledge partner in the field of 3D printing and digital manufacturing. Nitin ji is one of the first few torch bearers of additive manufacturing in the country, with a huge experience in 3D printing technology over a decade. And he has also his own company, and which is providing end-to-end solutions. So I would request Nitin bhai to please address our students.
Thank you very much. Yeah, just give me. Yeah, good morning, everyone. Just wanted to know how many of you are mechanical engineers here? Okay, I'm from the students. Okay. And what are the other streams? Is there anybody from electronics engineering or tool engineering? Oh, okay. Sab tool wale hai. Okay. So, how many of you know what is 3D printing? Oh. So very few people are aware what is 3D printing. So before I start and I talk about what are the careers available, I should know I should tell you what is actually 3D printing. Is it correct? And you should know what a 3D printing can do for you. And I will talk about, and I will, where is the, so Shri Rapid is basically the enabling the rapid prototyping and rapid tooling and rapid manufacturing technology in the Indian market. And we are in this field since 2007. And before that, almost 10 years, since 1997, we were involved in 3D printing. So we are one of the first torch bearers or the initiators of this technology in Indian market. Me and my partner, we started this journey in 1997, and in Shri Rapid, we established in 2007. So our basic background of the company is we have close to 500 plus installations in various industries of different 3D printing technologies, as well as we have the, I mean, we can say that we are one of the pioneers in the field of 3D printing, and we have different applications of 3D printing and different technologies what we can do the 3D printing in. So these are some of the industries where we work, starting from healthcare, going into engineering, jewelry, defense, aerospace, nuclear, as well as automobile and automobile ancillaries. Some of the brands we represent, so we were only talking about mainly 3D printing here, the 3D system, 3D Ceram, BCN 3D, these are then BMF, these are some of the brands which are very big in 3D printing. And we will go to the slides where we can show you what are the advantages of 3D printing. So 3D printing is something by which you can make physical components from the CAD design in few hours without any tools. So if I say that some of the people who are aspiring to become tool engineers, maybe in future there will not be any tools. So in future there will be only digital manufacturing. So what is digital manufacturing or rapid manufacturing? Is you design, everybody is aware about CAD softwares. So you know 3-dimensional softwares. So these CAD softwares, you make complete 3-dimensional object, and from this CAD software, you can directly go for production without any tool, without any injection molding machine. So the part I'm holding in my hand, this is a kind of a car air conditioning vent, okay? Now, can somebody tell me how much time from CAD to this part would have taken? Can somebody guess? Approximately? No guess. Sorry? 2 hours. So she is knowledgeable. So she must have definitely worked in 3D printing. It is exactly 2 hours. This part has taken 2 hours. And this, so this machine is there upstairs. This is called figure 4 technology. And now tell me, there, परेश साहब के पास कोई टेक्नोलॉजी है 2 घंटे में बनाने वाला कैड से? So, अभी तक तो नहीं है. So this is the technology what is 3D printing, and this is going to change the world. And we are also doing packaging, sir. So we are also doing packaging. You know, this is also packaging. When whatever we do in plastic is all enclosures. So this is also a packaging. I'm not saying packaging like a package. This bottle is also kind of a packaging. It's an enclosure. So what we are doing in 3D printing is also kind of a packaging, kind of enclosures. So whatever products you see, you know, this mobile phone or this remote control, what you see is a package. Inside is electronics. So wherever you see any plastic product or any physical product, it can be 3D printed. And if you can imagine a technology like 3D printing which enables you to make a part from CAD design in 2 hours, so you can imagine the kind of opportunities this technology can produce. And suppose they release some cars in Diwali for special festival or some anniversary, and they want to make only 100 cars with different kind of what do you say is the this AC duct vent. They can do that. Can they do with tools? Why? The cost. Because every plastic part what you produce has to be amortized for the tool cost. If the tool for making this will be how much cost approximately? 2 lakh rupees. How much time? 4 to 6 weeks. So we are talking about making 2 hours one part. So I can make 20 parts maybe around 40 hours. I can have multiple machines. So this is what we talk about, just-in-time manufacturing, fast design to production, the advantages, minimum wastage. When we say minimum wastage, I don't have to make any tool, I don't have to machine any metal, I can directly make what I want. So I am not wasting anything. So this is also for, जो सासा बोल रहे थे कि for the environment. So this is definitely going to be very useful for the environment because we are not wasting anything here. So then we are also going to make component which injection molding cannot make. That is the biggest advantage, and people and designers have started realizing 3D printing as a technology where you can make something which you cannot make conventionally, and that's a big thing. And this is going to change the whole world, and is already changing the whole world. People are making components, people are making geometries, the designers have started accepting 3D printing as a way of manufacturing. So if you see around 25-30 years back when we had EDM and wire cut machines, they were very new at that time. So people are not knowing. We are not doing everything using EDM and wire cut, correct? We are not doing everything on milling machine and grinding machine. We know what milling can do, we know what grinding can do, we know what EDM and wire cut can do. Same thing, now the designers have started realizing what 3D printing can do and what 3D printing cannot do. So there is a big opportunities in the field of 3D printing because the whole world will be moving to digital manufacturing factories. We are talking about digital factories. So digital factories means from digital directly to part. So that's the digital factories. And you can imagine the kind of manpower will be required, the kind of thought process will be required, and you young students will be basically part of this revolution. So some of the disadvantages and limitations you can see, you can do at present low volume production. You cannot do high volume production. So if you say I want to make millions of parts, unfortunately it is expensive. Then we are limited in build size. We are limited in material properties. So different things we have limitations also. We have advantages, we have disadvantages also. Okay? So this is the complete digital manufacturing workflow which my colleague will be talking about, the reverse engineering and designing softwares. I am talking about digital manufacturing, and inspection and post-processing is my colleague will talk again. So these are the complete workflow our company is offering, and we are always looking for the young students to get into this stream, understand this technology and take this technology further. Because if you ask me, it is not only mechanical engineers or electronics engineers or CAD engineers field. 3D printing is anybody who is creative is the field for them. So anybody from fashion industry here? Nobody from fashion industry. Sorry? Okay. No, they use plastics. So हाँ, fashion के consumer है, I know that. So if somebody wants to make some very nice, आप क्या बोलते हो बाल को लगाते हैं उसको, hair bands. You can make your customized hair bands using 3D printing in your own color, in your own design with your own logo.
Plastic or gold?
Plastic. Gold, if you can afford, yes, we have technology for gold. But since I am talking in AIPMA, I restrict myself to plastic. Otherwise, Arvind sab gussa ho jayenge. So, what are the different technologies? So, the first is the SLA. And I am very fortunate to be associated with 3D Systems, who are the originator of this technology, who brought this technology into the existence. And 3D Systems is still leading this technology and still evolving this technology, taking out new applications. So I'm really, since 1997, I'm associated with this technology and this manufacturing company. And this is really exciting technology. First was launched with SLA. Here we take the laser, with the help of laser, you can see we cure the resin and we make the part layer by layer. So this is how the SLA parts, and we can make from 10-inch cube going up to 1 meter, 1.5 meter part size. So what part you see on the platform is basically car front bumper part. It's actually not a car, it's they call in US, they call MPV. It's some kind of SUV type of vehicle, and this is what that part is. The second technology is DLP. This is what we have in our center in AIPMA here, which you can see. And this is a very small machine which goes into any corner of any room, and you can see it builds this type of part. So I want this part to be circulated so that everybody can feel this. And this part we can give to the other room. So whatever parts you see, whatever is circulated, these parts are directly built on the machine which is upstairs, which is figure 4, which works on a DLP process. Here we have a projector, and it projects layer by layer, each layer, and directly from the CAD design, this part is made. There is no finishing done on this part. This is the part come directly as it from the machine. So this is the DLP, this is digital light processing technology, where we project layer by layer. And the third technology is selective laser sintering, where we can actually print parts using plastic polyamide powder, using laser. This is another multi-jet printing technology where we actually use print head and we print the parts on the platform. This is widely used in jewelry industry for wax printer, wax pattern manufacturing. The third technology is about fused deposition modeling. Maybe many of you must have seen this technology in your colleges. FDM, that's what called, it's also called FFF, free form fabrication, where we use ABS powder and we actually layer by layer make the part. And the last one is metal. We can directly print metal parts. So all these 6 technologies, what you see, 3D System is the company which is a pioneer and leader in all the 6 technologies. There is no manufacturer in the world who has all these 6 3D printing technologies under one umbrella. So when you are coming at AIPMA 3D printing center, you are going to work on the latest state-of-the-art 3D printing technologies who are leading this field in terms of different applications. So this is, I really thank AIPMA to give us this opportunity to demonstrate this technology. And why I say it's important for the students to learn this technology, because this is what industry is using today. When you go to the industry, this is what they're using today. So what we can do in the education in 3D printing field is something what you can see, that we can develop this type of technologies, we can make a big know-how based on these technologies, because when we go into the industry and when we sell this technology to the market, they are looking for designers who can do designing and additive. They are looking for operators or managers who can manage the 3D printing shops. They are looking for people who are going to do consulting in 3D printing. We ourselves need application people, service people, the people who are going to repair these machines, the people who are going to train the customers. We are always looking for the people, and we don't get experienced people, so we train them. So that is one of the biggest bottleneck we have. So what you can get at 3D printing course at AIPMA with the help of 3D Systems and Chile Rapid Technologies is you can get the experience on the industry leading 3D printing technologies. the software is being used, how the applications are developed, you can actually develop, you can grow your career, you can develop your know-how, and slowly you can also try to see what opportunities, where you fit yourself, whether you can be a designer, or many of you can be an entrepreneur. Using 3D printing, you can start doing a job work. There is a lot of business for 3D printing, because 3D printing is something which is very, very limited even now in the market. So there are a lot of opportunities, and I have myself set up close to 30-40 companies. My customers, I help them to set up, to start service bureaus using these technologies. They buy one machine, after 6 months they come and buy second machine, third machine. So I have companies now with having turnover of around 200 crores, starting with 1 crore turnover maybe around 15 years back, only doing 3D printing. So that kind of opportunities are there. There is one company here in MIDC, walking distance from here, you may be knowing the name of the company, Imaginarium. They started in 2000 with one SLA machine. Now they are 250 people, 100 crore plus worth turnover, and around 18 different technologies, and they are one of the leader in 3D printing services in Indian market. So those kind of, anybody from you can become next Imaginarium, set up a business, in 10 years you become to that level. So that's potential is available in this technology. So 3D system, as I said, it's a pioneer in 3D printing, and they started in 1986. That's when the 3D printing was launched. And the person who's called Chuck Hull, he is the father of 3D printing, Dr. Chuck Hull. He is still the chief technology officer of this company, age 86, every day working in lab even today. So he is now, you can imagine what is the history of this company. He started this company in 1986, and today he is age 86, every day working in San Diego in the lab, and you'll be surprised what is working today. He's working on regenerative medicines and bioprinting and making human organs using 3D printing. So last 2 weeks back, he presented a lung manufactured using 3D printing. So you can imagine the kind of exposure this 3D printing technology can have. And now we are also doing some projects. We did also in metal printing, we did also a lot of work in healthcare. You know, we went through COVID, and we had close to 50,000 cases in India who lost their zygoma and all the maxillofacial bones due to black fungus or mucormycosis, what they say, they lost. And a lot of people were completely disfigured, completely their face. And we did almost 500 implants in last 1 year using titanium metal printing, using the complete CAD/CAM technologies. So this is really changing, and this would not have been possible without COVID, that people realize that this is also possible. So a lot of people have lost the complete nose using due to black fungus. So people are now making complete nose using silicon, using 3D printing technologies. This is one of the example. That's also a plastic, but that's for the human, and this is really helping the human. And if we are able to print the organs, human organs, that's going to be the very big advantage, and it's going to be next level of medicine. So this is the standalone figure 4 3D printer what we have upstairs, and I want every one of you to have a look. My colleagues will be able to show you live part building of this machine. The gray and black part what I circulated, I definitely want those parts back, but I want you to understand how this part is built on this exactly the same machine. These parts are built. So this is how the part is built. This is the schematic. You can see layer by layer the part is built upside down. It doesn't happen that fast, but it's a schematic. So it happens maybe in 20 minutes or 1 hour or 2 hours depending upon the part size. Different application of this technology, we have a lot of different materials. We have close to 30 plus materials, and new materials are being launched. Now, most important, what are the opportunities you have in 3D printing? And what are the jobs you can have? I am looking for people as a trainees or as engineers who are mechanical and electronics engineer who wants to do career in 3D printing for service application using 3D printing technologies. Then sales people, so people who can introduce it. We are looking for sales application service, because that is what we do. We introduce these technologies, we work with customers on different projects, and we supply these machines. After we supply, we need to maintain those machines. We need to support these application, these machines. So you can see we have operations manager, printing technician, additive manufacturing engineer, application engineer, additive design engineer. That is going to be a new concept. They call is DFAM. This is designed for additive manufacturing. So this is going to be a new design engineering stream, which is already, if you go to the big multinationals, they already have a DFAM with 100, 200 engineers. They are doing this work already in 3D printing and taking advantage of this technology and trying to develop and design products using 3D printing. So these are the roles what we can offer, and basically the people with electronics, mechanical, instrumentation, or production engineering, or metallurgical background, people can actually do excellent career in 3D printing. And you know, when there is a demand is less, the supply is less and demand is more, you can demand higher salaries. So that's one of the luring, I can say, in this field, that you can actually get very good salaries because there are very less people in the market. And if you develop the know-how, people want experienced people. And that is why we train a lot of trainees in our company. Many of my colleagues, they started in our company as a trainee, or they started with 1 year experience, and now they become expert in 3D printing. So that is what I say, that I always tell young students that please get into this field. It's a next upcoming field, and a lot of job opportunities going to be available. So there are some people, they are comparing 3D printing opportunities to the opportunities in the IT industry. So like India drove on the wave of IT, and so many people got jobs, so many big corporates got set up like TCS, Wipro, HCL, all these companies. Same way in 3D printing, there is going to be a huge manpower requirement worldwide. It's not in only India, it's worldwide, because this is what we are seeing, the revolution in manufacturing is coming up. And when you say we missed the industrial revolution in 80s, China and other countries they went very fast. But now what is happening with 3D printing, this revolution is happening simultaneously everywhere, and I am very glad to say that India is not behind in this wave now. So if you take advantage of this 3D printing and 3D manufacturing revolution, then we can actually we don't have to worry about that we missed the last industrial revolution, but at least in the digital revolution we can go very fast. So definitely there is going to be huge opportunities in this field, and you can talk to us after this talk, and you can come and see our live demonstration. So I'll ask my colleague Vivek to take further, I think 10 minutes he has to wrap up. I think there's a part of this. Okay. So you can, he can talk to you about digital inspection, white light inspection, and how we can do the advanced measuring and inspection technologies. Yeah.
I think so. Phones. Okay, anyhow, fine, no issue. I'm sorry, some fonts has gone back. Yeah. So once again, good morning, everyone. My name is Vivek Ajmera. So before I start, I just wanted to ask one thing. Like, I believe everybody would be, know about iPhone. How many of you like iPhone? Everyone, yeah. But what's so special about iPhone? Why everybody loved iPhone? What could be the things like? Any points, please, quickly, so I can I can wrap it up quickly. Sorry? Security, camera, features, process. So there is something about, right? Something unique about it. Why is so unique? Yes, I would say the quality of the product, the quality of the manufacturing quality of the product, or as we say, the quality of the camera is how it takes the photograph, or quality of the performance, everything. There's one thing is common about it is about the quality, and that's the reason it's perceived as a very good product or premium product. Because when we say as an iPhone camera, so it's because the quality of the lenses, the quality of the stakes, or the performance, it's because the quality of that performance of the product. So when it comes to a quality in industries, there's a one thing which is common and which first things come into any industrial mind is about Zeiss. The Zeiss isn't a company which is into the field, or I would say into the industries from like more than 176 years. They have been like many of people like in Zeiss. When we talked about Zeiss, people know about only the lenses, right from your spectacle lenses to the lenses which goes into a satellite or in telescopes and many other applications. Or Zeiss in terms of like I would say goes into for meteorological equipment and many other things. So Zeiss is in a company actually who are into a multidiscipline. Means they are right from the medical devices to lenses to an optical imaging systems to a metrology equipment system. So today I'm just going to give you a brief quickly about what kind of technology they have and how it can be useful and what kind of careers you can make it out of it. So first thing I'll just talk about Zeiss 3D scanner. A 3D scanner is a portable 3D scanner which can help you out to convert your concept, or I would say if you have any physical part, to convert into a concept into a virtual model and that make designs or iterations out of it. Or once you have manufactured it, what we need is a consistent quality, as we talked about today, the sustainability, time to market, product cost optimization or product optimization, everything. So at every stage of my manufacturing process, I need to do an inspection or a quality thing. And when we say the quality, I'm not talking about any measurement in millimeter or a centimeter. It's about in microns. So how many of you are aware about the microns? What do you mean by microns? What could be the decimal or what could be the measurements in microns, how it happens? Okay, good. So what do you think, what would the minimum micron level, or what would the hair, what is the size of our hair would be? One hair. Any numbers? Sorry? 1 micron? No. No. So it's something like, it ranges from the different thickness, but on average, I would say it's from 20 micron to 75 micron. Okay, so when I say the 20 micron is something like 0.020 millimeter. And when we talked about a Zeiss system, all systems are capable of doing a measurement in micron level and starts from as small as like 1 micron, as I'm talking about 0.001 millimeter. That's kind of a precision what it's delivered. So today the 3D scanner application is varied from a reverse engineering, concept designing to an inspection. You must have seen many movies like, right from Avatar to Bahubali and many other things. And we have set many kind of sets and a kind of thing. So today what they use a technology like a handheld scanner or a 3D scanner to capture any image or any shape or any profile. Or probably, okay, I can scan your face and I can make an animation out of it. And we have done it, like whether it's an advertisement or a movie or whatever applications you talked about. The same scanner, if you use it in industries, it can be used for the reverse engineering to capture that like physical into virtual. And once from virtual, again, I'm coming to the toolings or a final product or something, it can be used for the doing an inspection of those jobs. So we have kept one of our product over the display on the first floor in the meeting room, like the GOM Scan 1 is the latest technology. As a blue light 3D scanner, which can help you to convert a physical model into a concept model, or they're doing an inspection of the job. So this is something which I was talking about. On the left side, you can see is a plastic part, an actual physical part. On the right side, you can see the scan data of that part. So how exactly the process workflow is? So like as you can see on the left hand side, there is a scanner which is going to scan the part. On the top in the middle you can see the blue light is a steady scanning is happening, and at the bottom in the middle you can see the output from the 3D scanner. But from that output, what I can do many things. The same output, the output from the 3D scanner is in a .stl file, a stereolithography file, or a a 3D mesh model. Now this 3D mesh model, I can take it into a reverse engineering software and I can convert into a 3D CAD model for the downstream applications, like the CAD software what you must be aware about, like any CAD software you take about. Or I can take it as the same software for a simulation software for doing an FE analysis or a mold flow analysis or a CFD analysis and various other things to see the performance or functionality or behavior or virtual behavior or virtual testing of my product before I start manufacturing it in the field. Or I can send the same data to my 3D printers. So before I start getting into a production, I just want to get a form, feel, a fitness of about like how that product is going to look like as a new product development. Like when we talked about plastic, we all talked about consumer durable products or many other things. So that start of a design, I would like to understand what kind of design iteration is going to look like, or how it's going to feel, or how it's going to that form and everything would be. So rather than making a toolings probably from the different models or from the clay models of a concept model, I can scan, I can convert into a STL data, and the same data I can send it to the 3D printers and I can print it, and I can get the form 3D printed models to just get a form, feel, and other things like that. The same data, the same STL data, the 3D scan data, I can straight away send it to the CAM program, CAM software for doing an STL machining directly. I need not have to create a CAD model just to generate a CAM program. Directly I can send. And the last thing is about, okay, once I'm start going to manufacture the toolings or a final part or a different applications, I need to do an inspection. So now industries are moving from a human dependent inspection process to a system dependent process. When I say a system dependent process, so like there are lots of tools or solutions or systems available in the market which can help you to do an inspection right from the first toolings to the final inspection, enabling you to get a best result or the right product first at the right time. So this is a workflow. Once I have the scan data, then you can just go to the different model. Sorry, there are some fonts are missing in this. So once you have the object, you can get into a polygonized mesh, you can do the alignment and get it into a convert into a CAD, or you can import the CAD model, superimpose with the scan data, and you can do the inspection. So there are the two different main primary applications, the reverse engineering and an inspection of the whole solutions. Yeah, so this is about one of the example of an inspection. Like once I'll import the part, I can superimpose with the CAD model and I can do the inspection of the job. Then there's another system which is available from the Zeiss as a coordinate measuring machine, which you go to any industries who are into precision manufacturing, they must be having a CMM, to do the final inspection. When I say a coordinate measuring machine is a system where there would be a kind of a probe which will go through it was going to do a geometrical measurement or physical object measurement by sensing a discrete points. So when I say could be in a probe, could be in a form of a mechanical probe, optical probe, or a white light probe, or a laser probe, just to do a kind of a 2D measurements of the part. It's a very, very precise measurement systems. As just we in the starting, I asked measurement in 1 micron, 2 micron. This system are capable of doing a measurement in 1 micron, 2 micron of a smaller part to a bigger part in the market. So we have a different type of machines available in the market to cater the different needs and the different requirement and application of the industries, and have been widely used across various industrial segments. Not only the automotive, in any manufacturing segments you talked about. So we have got a breech type CMM, then we have got a gantry type CMM, and we have got a cantilever type CMM as well. So right from a smaller part, like small PCBs to a complete vehicle or something, can be measured using this CMM. And then once you have the data, you can just use it for a data collection. You can do the same like an inspection, or you can run the points and you can gather some points to do a reverse engineering, to gather some measurements, and you can start working onto it. Then we have some other machines like surface and form measuring systems, like whatever the machining I have done, like usually in the plastic, the end result or the end process would be the machining or something like CNC machining something. What we like to know is about the surface finish, how that surface finish is good, bad, or how exactly that is. So Zeiss has got a couple of machines like a contour measuring machines, rounded measuring machines, and roughness measuring machines. I won't go much into details of these machines. There are different machines. I'll just quickly run through that because just to cut short on the time. So contour machine is widely been used for the measurements of a surface profile technique for the smaller angles, radius, and distance across workpiece about the profiles, on the assembly line as well as on the shop floor or, individual components. Rounded measuring is just like a system or a device or a system to measurements of the roundness of the cylinder and the circular sections. So it can be used for some industries for even to test the measuring of particular standards or other industries like as well. Roughness measurements is to check the roughness and smoothness of the surface anywhere. So this is almost on everything you touch the feel, that like how that surface roughness is like that way. So this is a system which has been widely used for the surface roughness of this thing. Industrial microscope these are the small instruments which can be used to measure very small and tiny parts, right from your PCBs to a small, object, or a very tiny or small detailing parts, or a small thing. So again, they have a various systems: a stereo microscope, digital microscope, and metallurgical microscope. So if I talked about stereo microscope, is been widely used for PCB inspection, FIR analysis, a documentation, or a visual inspection of a small components, because it has a capability to magnify any small or any part which you like to measure by up to a 200x time. It zoom it out by 200x times. So you have a better idea. You can do a better inspection of a visual inspection, or you can find out what is the wrong, or what are the other things which have been produced or what have been designed is it right or wrong. A digital microscope is again for the same application, could be used for the various application of a document management like PCB inspection, 3D inspection, and micro components. So this is also like virtually in every field of inspection, and again this is also capable of doing a zoom of about 200x times. Metallurgical microscope is again used for to do an inspection of material analysis task, developing of a new material for a demanding or a new challenging requirement of the customer related to quality. It also has especially a technology called CDICE, circular differential interference contrast, and polarization contrast, to capture some better data about the phase analysis, particle analysis, FIR analysis, or a layer thickness analysis of a different material to identify the different algorithm or different patterns of that material what you use. And then just like similarly what we have in biomedical, or normally like when we have a fracture or something, doctor advises to go for an X-ray to understand yaar kaun si haddi toot gayi hai. Similarly, for an industrial product, like when if I produce any part, but there could be some kind of a manufacturing defect or issues within the part. So without cutting or without disturbing or without doing any physical damage to the part, there are some X-ray machines that are available for physical components from the size. So where we can take an X-ray scan of a part to identify the internal defect of those parts. So whether it could be a plastic, casting, ceramic, forging, any different parts we can get, and we can have an internal assessment of the part, whether is there any kind of issues are there or no. So there are like Metrotom is a product from a Zeiss which can be used for the 2D and 3D X-rays of the part components. So what kind of different roles are available, as more and more like within Make in India and a lots of competitive market where there are lots of new competitions are coming every day. So all the manufacturers, all the industries are moving towards building the product right at the first time, optimizing the cost, optimizing the development time. So there are lots of stress, so lots of focus on quality. And everywhere in the industries need a quality. So whether it could be a design engineer, or could be a gauge engineer in automobile companies, quality engineer in the manufacturing industries, global quality engineers, or a marketing, a sales engineers with an OEMs, application engineers with an OEMs, or scanner programmer, software. So there are various fields. Like if we just take an example, an automobile. So right from as a smaller child part, a small components from the nut and bolts to the final vehicle, all across that manufacturing process, there are the quality tests has been done by the various persons, various experts, the various level of people. So there is a tremendous opportunities for the experts, for the students are there to take up the career in the quality. So there are lots of things, like if I talked about from the industrial perspective, it could be an incoming quality, in-process quality, final delivery inspection quality, or in-house quality, or machine shop quality. There are various departments, various roles, various fields where you can build your career accordingly. So we offer a complete hands-on training, industrial visit, and we help you to become an industry ready, so that the industry can absorb you very quickly, and they can assign you the required role or specific roles based on your skill sets and your expertise, or based on your vision where you like to go about it. So there are lots of companies across different industries who have been using different technologies, especially the additive manufacturing or 3D scanning or 3D thing. So you take it any industries. It's not only about automobile. It's about consumer goods, about fashion industries. It got about manufacturing industries. You take it any industrial segments. Everybody been using the different technology, and there's lots of good job opportunities. There's lots of good career opportunities there for the students, experienced professionals as well. So we say a good education is a foundation for the better future, and with this, I'll conclude our presentation and I'll dash to the things. So once again, thanks for giving us an opportunity and giving an idea about this whole technological solutions. Thank you, AIPMA.